Hello students, now we will be solving memory-based questions of GATE 19. For more video solution on GATE 19, subscribe to our channel and don't forget to click bell icon for instant notification.
Hello friend, I am Gaurav. In this video, we will be solving the question from subject name process control. And the topic name is type of control system. The question is given as, you can see the question, the cascade control system has two control system loop. The first control system loop has time constant tau 1 and the second control system loop have time constant t2. So what should be the relationship between tau 1 and tau 2? The four option is given as tau 1 is equal to the tau 2, tau 1 is greater than tau 2, tau 1 is less than tau 2, and tau 1 and tau 2 are independent to each other. So here the question is coming from the process control. So according this way, cascade control is basically the two control system loop, that is your feedback and the feed forward. So first I introduce what is the feedback and what is the feed forward. So if you look at that, I start the question, I am using any feedback path. So my process, I want to control the temperature of the tank, that is my process. So here, that is my set point. That is my controller. That is the final control element. And that is my process. And the output will be the control variable. Control variable means I want to control the temperature of process. The control variable is the temperature. And this is my feedback. So what happening here? I want to control the process. So what happening? This is my control variable. Suppose my set point temperature will be the 25 degrees Celsius. Suppose I got the control variable temperature how much? 23 degrees Celsius. So this feedback signal should be compared with the input side. What should be the input side? My set point. So here total error will be the 2 degrees Celsius. This is given to the controller. It means my temperature is the less than set point. So definitely we will increase the temperature of the tank. That is my temperature in the tank. So here that is my final control element. So this controller give the signal to the final control element, that is my valve, that supply the steam to the process so that my control variable is going to closer to my set point. So that is my process is going on. It means my control variable is controlled with the help of some feedback loop. So what is the disadvantage of this feedback? Suppose any disturbance will be happening here. Any disturbance will be happening. That is the inner disturbance. So this disturbance can be anything from the chemical process. So if suppose any disturbance will be happening, so definitely the temperature of the process is going to change now. Then again, this control variable is going to your feedback path, then again giving to controller, then again to final control element, then it will control the process. So definitely it will take more time to take the action. If any disturbance to be happening here, it will take more time to take the action. So that definitely my process is going to slow. My process going to slow due to the disturbance. Suppose this process time constant will be the tau 1. Definitely tau 1 will be very high. If any disturbance will be happening, definitely my control variable is going to the feed forward path, feedback path, then is given to the controller. Definitely it will take the more time to take the action. So definitely my time constant tau 1 will be very large. That is my feedback problem. If a disturbance will be happening, my process is going to very slow. Definitely my performance is going to degrade now. Then to improve the performance, I will go for feed forward path. So in the feed forward path, I apply the control system in the forward path. So suppose this is my manipulated variable. Manipulated means I manipulate the temperature so that my process is going to control. The next I am going for the feed forward path. So basically the cascade control is the cascading of feedback control system and the feed forward control system. So if I am going to the feed forward, definitely control system is used in the forward path. So I am taking only forward path here. So that is my the manipulated variable that is coming from the controller. That is the manipulated variable. That is my the valve. You can say the final control element. That is my valve. That is my valve. And this is going to the process, and that is my control variable. And this control variable is to be coming here. I am not seeing to the other part because that is not important. So here, if any disturbance will be happening, that is my the inner disturbance, and that is my some controller. I am talking the feed forward controller. Feed forward controller. So what happening here? What is the importance of the feed forward controller? That enhance the performance of this process. So suppose any disturbance will be happening, this disturbance will be sensed by the feed forward control system, and that is given to the final control element. So definitely whatever the disturbance to be seeing here, definitely we can control or control the process in the forward path. So any disturbance should be happening here, it will be sensed by the feed forward controller, that is control the manipulated variable, how much amount valve should be open and closed based on the disturbance. So definitely I will not go to the feedback path, that is feed forward path is enough to control this disturbance. So definitely if I am talking this feed forward, so definitely any disturbance should be happening, that will directly control by the feed forward. So my process is going to very fast here. So definitely my process going to fast. Suppose feed forward controller time constant will be tau 2. Time constant will be tau 2. So definitely tau 2 is very less in the feed forward path. Then I will go for the cascade control. So cascade control is basically what? The cascading of the feedback control system and the feed forward control system. Then I will go, then you will be easy to analyze this question. So then I am going for the cascade control, that is the cascading of the feedback control and the feed forward control system. So if I am using here, that is my set point, and that is my the primary controller. That is my primary controller. So this is my primary controller. This is primary controller give the set point, the feed forward. That is my secondary controller. That is the secondary controller. Then I am going for the final control element. That is called your valve. That is called valve, and that is basically your disturbance, and that is my process. That is my process. And this control variable is feedback to the input side. And that is my the disturbance will be happening. That is inner disturbance. this one is my the feed forward path. So you can see that is my the outer loop is the feedback path and the inner loop is the feed forward path. So if you take the first control system having the time constant is tau 1 and the second control system having the time constant is tau 2. So according to the disturbance point of view, suppose this part doesn't exist, definitely the system is exactly same as the feedback. So if any disturbance is to be happening in the feedback without your feed forward path, so what happening? It will take more time to control the process. Definitely tau 1 will be very high. If you apply the feed forward in the feedback path, what should be happening here? If any disturbance will be happening, it will be captured by the secondary controller. Based on that, it will manipulate the final control and control the process that will be affected by the disturbance. So definitely tau 2 is very less, because if you are applying the feed forward, definitely my process is going to very fast now. So definitely, according to this question, my tau 1 should be very high compared to the tau 2. So this tau 1, the time constant of the feedback, is very high compared to the time constant of the feed forward control loop. So according to the option B is the right answer for that. That is cascade control system. Tau 1 is always greater than the tau 2. Hope you like the video. Don't forget to like and share with your friend. Thank you.